So it's quite clear that we're in this package of fine sands coming through here, and they're really steeply dipping. And there's all sorts of beautiful sedimentary structures. There's cross beds and ripples. There's little pulses of soft sediment deformation, little flume structures and so on. And there's a great place over here to take a strike and dip. And because I can tell already that this area is going to be structurally complicated, I'm going to be taking strikes and dips a lot more frequently. Striking 195. And dipping 80. It's steep. So we've just come in from a package of rocks that were dipping really, really steeply to the east. We can see those same rock types in here, same sort of strike and dip, but then we can trace individual beds, these sandy beds here with the limonite stains, coming around and wrapping right tightly around here in an isoclinal fold, and actually starting to dip the opposite direction. They jut up against this nice sharp fault, brittle fault that cuts right along through here, and you can see little bits of that syncline forming here. And now the beds are dipping the opposite direction. And so I'm going to get a strike and dip of these, and I'm going to pop it on my map. These beds here now are striking about 005 and dipping about 50 degrees. So it's quite clear here we've got a folded sequence of rocks. We've just come through this antiform there, and now we've come into this synform. And when you're in really folded rocks like these, it's critical to keep an eye on which way the rocks are younging. What is the up direction? Now we're lucky here because these rocks have got all sorts of primary features. They've got cross beds, they've got ripples. So it should be pretty straightforward for us to know which way is younging, which way is up. And if we are able to establish that, then we can call these things anticlines and synclines. Now I just come through the package of rocks. I knew that they were dipping in this direction and they were younging up. And so I'm very happy that we just walked through a nice syncline there. And the rocks here, if you look at this limb here, they're younging in that direction. They come around here. We've got a beautiful anticline hinge. Now, critical as well is when you see these folded packages of rocks, we want to know what the fold axis and axial plane are doing. So I pull out my trusty notebook here, I line it up with the fold, with the hinge of the fold, and get some idea about what plane intersects all those, the hinges of all those folds and the fold axis. And that is going to be the measurement of the axial plane. And the fold axis itself, I'm going to use a pencil and I'm going to just put it right on the hinge of that fold. These folds to me look like they're plunging very gently towards me. They're also cross-cut by faults, and so I'm going to try to measure the strike and dip of the faults and see if they've got any striations on the fault planes, because that will allow me to understand the kinematics of faulting. I'll put all that picture together and that'll really give me an idea of the structure. So I'm lining up my book with the axial plane of this fold best I can, and taking a strike and dip of that plane, which basically gives me the orientation of the fold. It's striking due north and dipping about 60 degrees. The next thing I'll do is the fold axis. Looks like these folds are actually in this spot plunging very, very shallowly, something like this, just towards me. So the trend is about 160, and the plunge was about 5 degrees. We'll see what happens to those folds as we walk around. But certainly we're really interested in their orientation because they tell us something about the direction of contraction. So structural geologists were really interested in the orientation and the geometry of these folds because they tell us something about the forces that were forming them. So in this case, of course, we've got these syncline and anticline pairs, and they're sort of oriented like this. That's telling us about a compression direction. That's shortening these rocks and folding them up like a rug. The other thing is they're interacting with faults. So some of the folds are becoming so tight that they can't tighten anymore, and they begin to get slip on bedding planes. They begin to have faults propagating through them and so on. So there's a bit of a transition and a synchronous kind of interaction between folding and faulting. Sometimes we get faulting first that propagates into rocks and causes them to fold. And sometimes we have folding first that ultimately leads to faulting. And so understanding that kinematic progression is actually quite important for us. So one of the things that really stands out with these packages of rocks is that you've got these beds of sandstone, these reddish colored beds that are sticking out more proudly from the rock, a bit more intact, coarser grained, and they're red color because fluids have been able to permeate through them a little bit more easily and sort of form iron oxide minerals and so on. And then you've got these finer grained beds made of silts and muds that are eroding more rapidly, and that's what's giving this rock its texture. But why this is important in a structural geology sense is you can see that the faults, there's a lot of what we call bedding parallel slip. As the rocks are being squeezed and shortened and deformed, there's a lot of sliding going on in between the layers, in the weaker layers. And every now and then one of those faults might sort of cut its way up across several beds and then rejoin another bedding plane. Just a way of these rocks accommodating strain. They're folding, there's a lot of bedding parallel slip going on, and they're faulting as well. And when this happens in an environment where the fluids that are coming through the rocks might host a lot of oxides and potentially some be able to precipitate some valuable minerals like gold, for example, it tends to concentrate in areas where the rocks are peeling apart and where there's some space being created. And when people go into areas where they're potentially economic, often that's where we find quartz veins, calcite veins, and there can be a concentration of elements like gold in those particular examples. Oh, this is a real beauty. So we've been walking through a package of rocks, north-south striking, dipping to the east and coming in, and then we can see them all just wrapping around here in this beautiful anticline. So this is obviously a great place to get an axial plane measurement and a trend and plunge of the fold, to measure the strikes and dips and even plot the different strikes and dips on the map as you change going across here. Use your anticline structural symbols to trace the axis of the fold and represent it on a map in that way. One of the other interesting things you see is a little bit of folding and thrusting in the hinge of the fold there. So lots to see. It's quite exciting when you come across these beautiful structures in the field.